So I'm going to reread that one part for everybody. So 7.1 or 7.3 notes it says a dilation is a transformation that enlarges or reduces a figure by scale factor. The pre-image and image are similar figures. Okay, so it's the same figure but enlarged or reduction. We were kind of talking about that yesterday with similar figures, right? So they're kind of a dilation, a smaller or a bigger version, but it's still the same version, just bigger or smaller, okay? An enlargement, a figure that gets bigger from a pre-image to an image, so it just gets bigger. And a reduction, you know, you can think of pictures too. You can get an enlargement on a picture. You can reduce a picture down to smaller sizes. A figure that gets smaller from a pre-image to an image, okay? So right here they're discussing that the scale factor for a enlargement, for it to get bigger, is going to be greater than 1. So anything, if I can enlarge it by 1.1, it's going to go up, right? Because 1 is the same. If I multiply something by 1, it's just the same number, okay? If I multiply something by 1.1, it gets a little bit bigger, right? So let me show you. So say 5, if I multiply by 1, I just get 5. If I multiply it by 1.1, I get 5.5. That's just a little bit bigger, right? But if I multiply it by something less than 1, for example, like 0.9, I get less than 5, okay? So that's a reduction. The pre-image is the original image before transformation. These are all transformations, okay? A couple of different things go into that grouping, but this is what we're going to talk about mainly today. The image after a transformation labeled with blank to represent the new points, we call that prime. Okay, usually it's like a little, see this little 1 right here? That's kind of a prime symbol, okay? So when you transform a figure or you dilate it or reduce it, you're going to put that little symbol by it, okay? So look at the first one. It says example 1, a triangle has vertices C, which is -2, -1, D, 1, 1, and E, 2, -3. Find the coordinates of the vertices of a triangle after a dilation with a scale factor of 2. So the scale factor is 2, so that means we're going to enlarge the figure by 2. So you take each point. So you say -2 times 2. What's -2 times 2? -4. So C prime is going to be -4, -1 times 2. It's going to be -2. Okay, so that would be your new point. So that's all you're doing. You're multiplying it by 4 and it's going out. 1 times 2 is 2. 1 times 2 is 2. 2 times 2 is 4. -3 times 2 is -6. So the coordinates are C prime is -4, -2. You should be filling this in with yours. Then D prime is 2, 2, and E prime is 4, -6. Okay? So all you're doing is you're taking each point and multiplying it by the scale factor. Okay, so that scale factor is going to tell you whether it's an enlargement or a reduction. Is it greater than 1 or less than 1? Okay? So example 2 has vertices S, 1, 3. So right here, 1. Does this go? Is it this example next to y'all's? My paper changes a little bit. Is it next example 2 on y'all's? Okay. Okay, 1, 3, 4, 3. It's jumping by 2. 5, 1, and 2, 1. Graph the figure. Okay, so, and its image after a dilation with a scale factor of blank. It didn't keep the number, so what is the number on y'all's? What? 1/2? Okay, so for some reason when it converts, I'm trying to figure out a way when somebody shares it with me, it's not letting me save it as a PDF, so I'll have to figure out a different way. Okay, so we're going to take each point and multiply it by 1/2. So what's half of 1? So 0.5 times 1 is 0.5, right? Okay, and 3 times half is 1.5. So that new point, okay, so on S1, they labeled it 0.5, 1.5. Do you see how they did that? So this little gray image, the little lighter image, is at the transformation. It's the reduction. It's the same figure, but reduced. So the second one, you would say 0.5 times 4, which would be 2, and then 2 and 1.5 would be T1, T prime. Are y'all seeing where this is coming from?
Yeah.
It's pretty simple sometimes. Okay? And then half of 5 is 2.5, half of 1 is 0.5. So that's U prime. And then 1 and 0.5 on the V prime. And they've labeled these points already on there for you, okay? And connected them. Do you see where they got all those? No? Yes? No? Okay. So right here, I took this point, like say it's 4, 3. And I multiplied. And so on your paper looks a little different than mine. So I'm sorry about that. So I'm going to write it over here. I'm going to say 4 times 0.5. And why am I doing 0.5? Because the scale factor is half. Well, fractions, I'd rather deal with a decimal personally, right? So half of 4 is 2. So that's my answer. So that's where I got this right here. This first number. Okay? And then I took my next number, which is 3, and I said 0.5 times 3, and I got 1.5. So that's my second number right there. Okay, so what's half of 5? It should be, I think it's leaving a blank there. I'm sorry, it really looks different. So half of 5 is the 2.5. Half of 1 is 0.5, right? So that's where I'm getting those numbers from. Do you see that a little bit better? Okay, because my scale factor is that right there. Okay, so then they took over here and they went and placed all those dots. So S prime, see it's marked right there? S prime. Let me go over this just in case, okay? S prime, we decided was 0.5, so 0.5, 1.5. So that's that dot right there, okay? T prime is 2, 1.5. And then U prime is 2.5 and 0.5. And then V is 1 and 0.5. Okay, how do you feel about that so far? Okay, so then they just connected all of those points and made our new parallelogram.
So you just multiply.
We take each point and multiply it by whatever the scale factor is. Reese, it's recording all your tapping too. Okay, so if it's greater than 1, we would scale up. Okay, so that's how they did. Now let me look at example 3.
What class are you showing these to? All of them?
Well, all the people that are absent mainly, but okay. So okay, let's look at this. Zach has a toy bicycle that is 2 inches tall, an actual tricycle that is 16 inches tall. What is the scale factor of the dilation? So it went from 2 inches to 16 inches. What do you think?
8
times 8. So the scale factor is 8. So write a ratio 8 to 1. Okay? Okay, so determine the coordinates right here. Okay, so on number 1 on the practice problems, what does it give you as the scale factor? It does on this one right here?
Yes, it does. It says
Oh yeah, K equals 1.5.
Okay. Okay, so on all of them?
no. On number 2, it's 2.
Oh, here it is. It is right. It gives me K equals 2 on there. Okay, so we're going to take each point. Okay. Yeah, we're on the back now. Okay, so let's look at, because it didn't.
It like has this and then it like has this on the back.
Okay, sorry. Okay, so let's look at J. So we're going to do J prime. Okay, so let's start with 1 point right here. So we're multiplying it by half. So my first point is -4. So half of -4 is -2. And then half of -1 is
-0.5.
-0.5. Our numbers are going to stay the same. Okay, I mean, if it's a negative, if it's multiplied by a positive, it's going to stay negative. So K prime is going to be, half of 0 is still going to be 0. Anything times 0 is 0. And then half of 4 is what?
2.
Okay, 2. So that's K prime. So we've done both of those. And then L prime.
-2.
So half of -4 is -2. Half of -2 is -1. Okay? So looking at that, we have -2. These are our original points. They've already graphed our original points. That's what that black thing is, okay? So -2, 1, 2, -0.5. So that's my first point. Danny, are you with me or no?
Why barely go?
Okay. Are you sure?
Yeah. Hey, wouldn't it be?
Okay. Okay, 0, 2. Stay with me for a minute and then we'll see. -2, -1. So if I can connect those points, look. It makes a version that's about half the size, right? Okay, it's just scaling it down is all it's doing. Okay? Too fast? A little? Okay, so let's look at this one over here.
Do we graph those?
Yeah. So right here they told us the scale factor is what? 2. So now we're going to take everything and multiply by 2. So look at R. R is -2. Oops, sorry, I didn't even mean to do it. -2 times 2 is what? -4.
It's supposed to rain.
Okay, 1 times 2 is? What's 1 times 2? 2. And then, so this is R prime because it's the new version, okay? The next is A prime. So 1 times 2 is? 2. 1 times 2 is? 2. And then I, 0 times 2 is?
0.
0. And then -1 times 2 is? And then N prime.
That's supposed to rain.
Okay, so if I graph these points, -4, 2, 1, 2, 3, 4, 1, 2. This is R prime. A prime is 2, 2, 1. I prime is 0, -2. And then 2, -2, -2, -2. It should be a enlarged version of the first version. Sometimes it's going to be smaller. If it's anything less than 1, it's smaller. If it's anything greater than 1, it's going to be bigger. Okay? So everybody see where we're headed with that. Okay, I want you to try the next 2 on your own. Okay?
Go back.